Alright, this is your 5.5 notes, and we're going to take a little break from systems today, which you might be wondering why, because this is our systems unit. But before we can get into systems of inequalities, I needed to show you how the heck to graph inequalities, because we've never done that before. So we're just going to kind of take baby steps into tomorrow, but just know that this is going to help us branch into what we're talking about tomorrow. So basically, all I'm going to ask you guys to do today is to graph linear inequalities. We know how to graph linear equations, but we've never done inequalities before. So in equations, there's just a set point of what x is and y are equal to. But when we have inequalities in here, that's where it gets a little tricky. So your job when you're graphing linear inequalities is you're going to show all the ordered pairs where the y value, in this case, is greater than or equal to the x value. Sorry, or equal to. So let me show you what I mean. So essentially, it's very similar to graphing equations. This is your b, this is your m. You're going to do all of that the same way. So let's go ahead and do that. So we're going to start at 1, and we're going to move up 2 over 1, up 2 over 1, up 2 over 1. But instead of just drawing your line here, now this could be equal to that. So we could draw, oh, my lines are terrible on this thing. I can't even stand it. So it could be equal to that. But what this is saying is that it could be equal to everything, or it could be greater than everything on this line. So how the heck would we show what is greater than this line? Well, this is where we're going to start our shading process. So everything that's above this line would be greater than this line. So what this shading is showing is that everything that is on this line and everything, all the ordered pairs that are above this line, could be the answer to our equation. Okay? So we have a solid line, and since it's greater than, we're going to graph above, or shade above. Okay, so this might be really weird because we've never done this before, but hang in there, it'll come easy to you. So let's look at this one. Same type of problem, except it's not equal to. So we're just showing everything that's greater than in this one, not equal to. So how are we going to show just greater than? So we're still going to shade above, like our first example. But in this case, instead of having a solid line, because it's not equal to everything on that line, we're going to have a dotted line. Okay, so it's going to be the same line, except that you're going to have a dashed or dotted line. So we have start at 1, up 2 over 1, up 2 over 1, up 2 over 1. We're still shading everything that's above our line, except we're going to have a dashed line because it's not equal to this line. It's just greater than this line. Okay, so let's move to something, a little key that will help us graph linear inequalities. As long as the inequality is in slope-intercept form, these rules are going to apply. So just remember that these are our symbols. This is what they look like, if you forget. If you have something that's less than, then you're going to shade below. Okay, so that's a helpful reminder. If you have anything that looks like it's greater than, oops, you're going to shade above, or shade up. Okay? Oh my goodness gracious, what was that? I don't even know. Alright, so then if you have these two where it's not equal to, it's just less than or greater than, you're going to have a dotted line. And if you have it could be equal to, you're going to have a solid line. Okay? So let's do some practice here, these two. I might have you do one on your own. I think I'm going to have you do example 2 on your own. I'm going to show you example 1. So just like what we were doing on the front, this is in slope-intercept form, so here's your b, here's your m. So we're going to start at -4. So 1, 2, 3, 4. And we're going to move up 1 over 2. So you're noticing this first part of this process is just like equations, just like what we've been doing. Everything else is where it gets a little different. So now before you draw your line in, is this a solid or a dotted line? It's not equal to everything on that line, so you're going to have a dashed or dotted line, just like this, but better than mine because mine always stink. So you're going to have a dashed line. That is just the worst. Okay, dotted line, and it's less than. Y is less than, so you're going to shade everything below that line. So all of these ordered pairs could be the solution to our problem. Okay, so not so bad, just a little different. I'd like you guys to try example 2, and then we'll go from there.